welcome to function notation. So you can use the function f of x equals 9/5 x plus 32 to find the temperature f of x in degrees Fahrenheit for any given temperature x in degrees Celsius. Find the specified value. So f of 15, that's how we say it, f of 15. It's not f times 15. I know the notation kind of looks like that, but this f is not a variable. It says it's a function, and we're trying to find the function value when x is 15. So see how there's an x here? This 15 is going to substitute in for the x in this part. Excuse me. So we're going to say f of 15 is going to equal 9/5, and instead of x we have 15 plus 32. Now I know this kind of gets confusing, and there will be some people who make mistakes on this because I see a parentheses here and I see a parentheses here, and I just think, oh, that's multiplying, so I should divide by 15. But that's not what this means. We aren't going to do anything to this. We're just saying find the function when x is 15. So all we have to do is evaluate one side. Okay, so all we have to do is simplify this side to get it down to one number. Okay, so I have 9 divided by 5 times 15. Well, 5 and 15, the 15 is kind of in the numerator, so I can take 15 divided by 5, and I get 3. So I've got 9 times 3 plus 32. So that's going to be 27 plus 32. And 27 plus 32 is 59 degrees. So there's A. Now let's do B. F of negative 10. So that means we're going to have 9/5. F of negative 10 equals 9/5. Instead of x, we're going to put in a negative 10 plus 32. All right, so 5 and 10, well, I can drop those down. This is going to be a negative 2. Don't forget the negative. So that's going to be negative 18 plus 32. So what's 32 minus 18? And that is 14. So f of negative 10 equals 14 degrees. Okay. Then C. Find x when f of x equals 41. So now we're going to replace this whole thing with a 41. So we're going to substitute the f of x this time with 41. So we're going to say 41 equals 9 divided by 5 x plus 32. So this time the 41 doesn't go in for the x, it goes in for the f of x, which makes sense because it says f of x equals this. So if you're good at substitution from the last chapter when we were talking about substitution method, this should come fairly handy for you because now we're just plugging in 41 in for f of x. So now we just have to solve this like a traditional algebra solving equation problem, right? So I'm going to subtract 32 from both sides, and I get 9 equals 9 over 5x. Now here's something you can do. I don't want to necessarily divide by a fraction. I don't like that. So I'm going to multiply both sides by 5, and multiply by 5 here, and these 5s will cancel out, right? Multiply by 5, divide by 5, cancels out. So I'll get 45 equals 9x, divide by 9, and I should know that equals 5. So I can say x equals 5. All right, and then the last one, D. Find x when f of x equals negative 4. So the same deal as the last one. We're going to plug in negative 4 in for f of x. We're going to have negative 4 equals 9 over 5x plus 32. And now we just have to solve for x. Subtract 32, just like we did the last one, minus 32. And that will give us negative 36 equals 9 over 5x. Okay? So now I'm going to multiply by 5. Multiply by 5. I'm going to put that in parentheses so I know it's a negative 36. And 36 times 5 will give me negative 180 equals, and then multiply by 5 and divide by 5 cancel out. I'll have to with just 9x. And then divide by 9, and 9 goes in 18 twice, so it should go into negative 20, should be my answer. So I have negative 20 equals x. And there's my solution for D. So sometimes if you see the number in for the x, you plug it in for the x. If you see f of x equals something, you take that thing and plug it in for the f of x, just like we did with substitution.